All right, let's talk about a model that's making some serious waves in the AI world. Moonshot AI's Kimi K2. People are saying it's the start of a whole new era for open source AI. With these powerful, autonomous agents that can basically think for themselves. But how much of that is the real deal and how much is just hype? Let's dig in and find out.
So the first thing that just jumps out at you is the headline number. A 1 trillion parameter model, and it's open source? That's a scale that just puts it in a completely different league. It's right up there with some of the biggest closed source models. So what exactly are we dealing with here? Is this for real?
Well, yep, that number is real. 1.04 trillion parameters to be exact. But here's the really clever part. Kimi K2 uses a special architecture so it doesn't have to fire up all 1 trillion parameters at once. That efficiency is absolutely key, but make no mistake, that sheer scale is the foundation for its incredible power.
And oh boy, that power is very, very real. Just look at its performance on SWE-Bench. Now, this isn't just some random academic test. This benchmark measures how well an AI can solve actual coding problems from real GitHub projects. Kimi K2 scores a 65.8%, which blows past a lot of well-known models. This thing isn't just big for the sake of being big, it's seriously capable, especially when it comes to messy, real-world tasks.
So you gotta ask, right? Why build a model this massive? Well, the answer really gets into Moonshot AI's super ambitious long-term vision. This was never about just making a slightly better chatbot. No, this is about creating a fundamentally new kind of intelligence.
And the key phrase here is agentic intelligence. This is the real game changer. We're talking about moving beyond AI that just predicts the next word in a sentence. We're moving towards AI agents that can plan, reason, use tools like a web browser or a code interpreter, and, get this, even critique their own performance to get better. They're designed to solve problems all on their own. This roadmap basically shows their whole strategy for getting to artificial general intelligence, or AGI. So layer 1, that's where most of the industry is right now, just making bigger models that are better at predicting the next word. Layer 2 is about figuring out how to get enough data. But Moonshot, they are laser-focused on leading the pack in layer 3, building these advanced agentic systems. And Kimi K2? Well, it's the centerpiece of that entire strategy.
Okay, so how on earth did they do it? What's the secret sauce that even allows a model this huge and this ambitious to work so well? Let's pop the hood and take a look at the technical magic that makes Kimi K2 possible. So, its core design is something called a mixture of experts, or MOE. Think of it like this. A regular, dense model is like one single doctor who's a generalist, trying to solve every single medical problem you throw at them. An MOE model, on the other hand, is like a whole team of specialists. You've got your heart surgeon, your brain surgeon, your neurologist. When a problem comes in, the system smartly sends it to only the most relevant experts. This makes it way more efficient, only activating a small fraction, about 32 billion, of its trillion parameters for any single task.
Now here's the thing. Training a model this huge is usually a nightmare. It's super unstable. That's where their brand new optimizer, called Muon Clip, comes in. It solves this really nasty problem, where the math can just spiral out of control and completely crash the training process. This quote right here shows you just how crucial that was. They trained on a mind-boggling 15.5 trillion tokens of data without a single major error. That's a massive technical win.
But they didn't just stop there. Building on that incredible foundation, Moonshot went ahead and released an even more powerful version called Kimi K2 Thinking. And this one is specifically designed to be a reasoning agent, really pushing the limits of what an AI can do on its own.
And get this, Kimi K2 Thinking can make between 200 and 300 sequential tool calls to solve just one problem. Just imagine telling an AI to analyze a big spreadsheet. It might need to load the data, then clean it, then run some stats, then create a chart, and then write a report. Kimi K2 Thinking can handle that entire complex chain of events by itself, without getting confused. It's wild.
Okay, so a trillion parameters, insane coding skills, autonomous tool use, it all sounds pretty incredible, right? But what does it actually take to use this thing? This is where we hit a bit of a reality check, the practical side of running this absolute beast of a model.
Yeah, as you might have guessed, a model this powerful isn't going to run on your average everyday laptop. We are talking about some serious hardware, starting with just the amount of space you need to even have it on your machine.
250 gigabytes. That is the bare minimum you need.
And listen, that's not just your hard drive space. That's your disk space, plus your system RAM, plus your graphics card's VRAM, all added together. That right there immediately puts it out of reach for most normal computers.
And this table really lays it all out. A budget setup that can even run it still needs 64 gigs of RAM and a top-end RTX 4090 GPU. And even then, it's going to be slow. If you want a smooth experience, you're looking at a professional setup with 256 gigs of RAM. So yeah, this is really a model you deploy on a server, not one you just run locally for fun.
But here is the major plot twist. While running it yourself is a huge ask, actually using it through their API is shockingly cheap. And this really shows you where things are heading. The hardware barrier is still very real, but API access is becoming the great equalizer. If you can't afford to build a supercomputer, you can just rent one for pennies. Just look at this chart. Kimi 2's API costs just 15 cents for 1 million input tokens. That is more than 5 times cheaper than Claude's Sonnet 4 and way less than GPT 4.1. This basically makes its incredible power available to almost any developer or business out there, no huge hardware investment needed. So what we have here is this brilliant, incredibly powerful, and surprisingly affordable model on one side, and a hardware-devouring monster on the other. So what are actual users saying? Let's check out some real-world feedback from the people putting it to the test.
I mean, wow, this user's experience is just amazing. They had Kimi K2 rewrite an entire application for just over $1, and they say it was accurate, no nonsense, and it nailed complex tasks on the very first try. This is the promise of Kimi K2 in a nutshell.
But then you see stuff like this. The exact same powerful model getting stuck in an endless loop, trying to do something simple like reading a file. It just goes to show you, while the model is brilliant, it's definitely not perfect. It still has its quirks and can fail in some really unexpected ways.
And when you look at enough user reports, a pattern starts to emerge. The most common problems, failing to use tools correctly, getting stuck in loops, thinking a job is done when it's not, are all related to those core agentic abilities. The very thing that makes Kimi K2 so special is also where it's still a little rough around the edges. It's pushing boundaries, for sure, but the road is still a bit bumpy.
So Kimi K2 is without a doubt a landmark achievement. It's a genuine glimpse into a future of powerful autonomous AI agents. The real question isn't just whether this specific model is ready for prime time today, but whether we're ready for where incredible engines like this one are going to take all of us tomorrow.